So as we continue with the development of obstacle avoidance on Rosie-bot, there's something to clarify here. There are two ways to do proportional control. One of them is the robot's speed is adjusted proportional to how close it is to an obstacle, where the closer the obstacle is, the robot speeds up. The other way to do it is based upon distance, where the closer the obstacle is, the further back the robot moves. I'm going to show examples of both of these. First, we're going to look at speed. So here I'm going to show that as my hand gets closer to the robot backs up faster.
Okay, here's our final installment in proportional control. Here is the one for obstacle avoidance proportional to distance. So the robot moves proportional to how far away the obstacle is. I am assuming that you've already watched the motion control, the avoid obstacle bang bang, and the avoid obstacle proportional speed control videos. So I will only highlight the new information. So first, under global variables, we have a max detect distance of 5 inches that can obviously be modified based upon your needs. Then at the bottom, after the motor variables, we have a move time, robot speed, which can also be modified based upon your needs, proportional speed, 1 second, 2 seconds wait time, and our state variable for determining location of obstacles. Inside the loop function, we have a for loop that increments from 0 to 3 and reads our sensor data. And then if the sensor data says that that particular location is less than the maximum detect distance but greater than 0, we set that state variable to 1. And then we use that detect distance in order to modify our proportional speed based upon the distance to the object. And then we use this to dictate how the robot moves. So if you look at our code below, you will see that if the obstacle is in the front, then the robot reverses proportional to the speed. If it's in the back, the robot moves forward proportional to the speed. If it is on the left, the robot moves proportional to the speed. And if it's on the right, the robot moves proportional to the speed. And if there are no obstacles, the robot either stops, or we've already talked about, you could then enhance your code so that the default position is then move forward when there are no obstacles, or randomly wander when there's no obstacles. And these functions are in the helper functions, and you can see those in our initial avoid obstacle bang bang control video.
No obstacle, obstacle, slow. You hear the motor starting up. And then as I get really close to the robot, it moves away quicker because it really wants to get away from the obstacle. And as I back my hand up, the robot slowly slows down. That is what we call proportional control. The robot's potential field says that the closer an obstacle is to me, the more I really want to get away from it. And top speed happens the closer the obstacle is, and then it slows down. And let's see what this looks like on the computer. No obstacles. Farther away, very low speed. As I'm getting closer, the robot speeds up.